Good evening, everyone. My name's Paul Field. My company's Parsec. This is more of a tech talk. We've been a consultancy for about 15 years, but we're doing some product work now. It's in the field of gesture-based applications. So this is just going to be a quick run through of what's happening in that field and what's possible. There's some pretty interesting stuff happening. So for anybody not familiar with the idea of gesture-driven applications, it's pretty simple. I can literally gesticulate, I can move my arms, my body, any part of myself. The computer can recognize a movement, and that can actually be interpreted into something. So games are an obvious application of that, but actually there's quite fast-moving, sort of quite stimulating area where people are saying, well, what could we do with more serious applications, more commercial applications? And you'll see words like natural interaction or natural UI as being coined for this kind of idea, controlling the computer with movement. And that can be anything from I'll do this and this, or it could be very specific framing, drawing, pointing. If anyone's seen the film Minority Report, you might have an idea of what I'm talking about, where massive, great big screens, size of the wall, very rich kind of graphical display, and the idea being I'll be able to interact with that data or the visualization of that data by moving myself rather than a device or a mouse or a keyboard. So how does it work? It might sound a little bit strange, but actually it's not a new technology. Field of computer vision is pretty old, actually pretty well established. A camera or multiple cameras can actually look at a person or persons and work out what they're doing. It's a fairly logical stack. A camera can actually depth sense what's in front of it. That data comes back into the computer, is analysed, broken down into blobs. Blobs are broken down into more meaningful structures like maybe a skeleton. And then because it's doing that, say, 30 times a second, if I do this, then actually the computer can work out I've made that gesture, or I've made that gesture, or I've run around in a circle, or I've waved my hand. But the point is, it can track my movement. Some of the devices that are out now can actually do sound as well. So if we're interested in vocal recognition, then that can be combined in there. You've maybe seen Microsoft have enabled that now with Xbox. So if you've got the Kinect device, I think probably they're trying to steal a march on Apple launching their TV with Siri, and you can go Xbox, change channel or something like that. It's probably not going to be as good as Siri if I'm any judge, but it's just an example. They've combined the technologies. And like I said, it's not really a new idea, but what is new about it is the fact that Microsoft launched a depth sensing camera for 100 quid. And that was pretty game-changing, because these cameras have been around for a while, but you could spend thousands on them quite readily, and that's not at a price point that hackers are going to pick up and play with, or that innovators are going to go, that's interesting, let's set that up and see what we can do. So it was really a pricing play, in my opinion. But then, in true style, Microsoft didn't really help the development community. They didn't want PC developers to use it. It was games only, no software developer kits. So I think immediately, if you look at the net, there was a lot of good ideas, people going, well, I could do this, I could do that, but actually no way to program it. And that situation lasted for a couple of months or so. But then somebody set up an X Prize. If anyone's familiar with the idea of an X Prize, of basically a sum of money for solving a difficult problem. It was quite a small one, but a little firm said, we'll give $3,000 to somebody who can hack the Kinect, come up with their own USB driver that you can run on the PC, and bang, plug in your Kinect drive into your computer, and you can start programming with it. Done within weeks. And it was called libfreenect. It was pretty difficult to program against, but it was done. Not long after that, there was OpenNI. So PrimeSense, which was the company that designed the chip that sits inside Kinect, actually kicked off something called OpenNI. with a couple of other people. And the idea being, right, this is getting popular now. Let's start an open source foundation. We'll release some middleware and try and stimulate some growth and see what comes of it. So that's a little bit easier to program against again. So more starts happening in the market. There's some more interesting demos coming out. And eventually Microsoft go, yeah, maybe we better actually release an SDK. So they did that, and then more stuff's still happening. And if you look at, there's a few websites, Connect Hacks, that actually show some really good examples that people have come up with. And next week, Microsoft are officially releasing their developer version of Connect, by which stage there's hundreds and hundreds of demos and examples that people have built without any help from Microsoft, really. You can Google this. I mean, if you just Google Connect hacking, you'll see tons of examples, and I've just put a couple in here. There aren't that many commercial ones yet. And this is an example of one very simple one. There's lots of retail things. I mean, things like virtual changing rooms or fitness applications, lots of quite fun things. But this is quite a cute one that somebody came up with, where you can actually control Office by, you'll gesticulate, bring up a controller, slide this way and that way through your slides. Maybe just looks a little bit more slick than sitting there with a mouse and going click, click, click. Somewhat, yeah, but it's with, the underlying data is slides. There's a video that you can go and see on YouTube that actually shows it in action. So it's a little bit richer than PowerPoint, but it is still basically a slide-based approach. And the video's set to music, classical music. It's quite fun to watch. And it goes on for quite a long time. I think they're just proud of their UI, actually, and they're showing it off. A couple of other slightly more serious ones, video manipulation. So I could draw a video player in the air. I would show the videos, but I know the internet connection is not very good here. So if I want to just do video manipulation literally in a large space like this, then I can do that. There was a more recent one someone came up with where this was an Egyptian firm that did this, where you can actually have a big screen and do contact manipulation and actually do telepresence as well. So if you actually want to interact with people in your network, then again you can point and wave and manipulate. And quite simple and quite interesting. The other thing that was interesting about video is finger tracking, because if you look at these cameras today, they're relatively low resolution, so it can spot me doing this or making strange gestures. But when it comes to point or frame or making more specific gestures like you might want, if I'm going to do that Minority Report style thing, then that's a little bit more difficult. But it has been done. It's a more difficult problem. You have to be close enough to the camera. You can't move too fast, but it is fast enough to be quite usable. It's commercially viable, I think. And if you talk to some of the commercial vendors of some of these tools, they're all ready with things about to come out to make this a much more serious proposition. If you want to do it on your own, you need some fairly serious maths and hacking skills to do it. But you can do it. And then for anybody who's interested in really rich graphics, and I think that does complement this kind of environment more naturally, then we've got games integration. So there's something called Unity 3D, which is a scripting engine that will allow us to build very diverse 3D models. So plenty of firms have picked that up and built like architectural environments. So if I want to do modeling of a building or a bridge or a whole world, then that kind of technology has been used. If you want to imagine actually flying yourself through or waving and zooming your way through an environment like that, it's perfectly possible now because several of the Connect tools are actually integrated to games engines. Same thing with Flash, if you like programming in Flash. Same thing with, there's another scripting language called Processing, which is meant to make it possible for non-techies to draw graphics. And it's a very simple language and quite, it's quite possible for people who don't really have programming skills to get things working there if they have an idea and they want to kind of show something off. So an awful lot of activity happening, and quite a few companies set up as well. There's a lot happening out of Israel because the chip, the light sensing chip for Connect actually came out of there. A couple of people spun out of that and founded Zigfu, which has got some very interesting middleware. So again, if this is a programming challenge to some companies, if they want to have gesture-based manipulation, then there's some good tools from them. Another one called OMEC just closed another $7 million to actually advance their product forward, and it's pretty good as it is. And cameras as well. So Panasonic have had a camera on the market for quite a while, but they've just launched 2 more. Higher resolution, higher quality. PMD is another one. Soft Kinetics, similar to OMEC, sort of the commercial space, so where Microsoft are giving the tools away and they're quite basic, some of these other companies come along and say, well, look, we'll give you a much more full-featured tool set, so you can spend much less time worrying about how to program it and more time actually getting your idea brought to life. So what about financial services? Is it relevant? How's it relevant? Well, I think it is, and we're working on a few examples. Navigating complex data. If you've ever, there's a TED talk on this by a guy called David McCandless, Information is Beautiful, the idea of taking very large volumes of data that's quite difficult to visualize, actually coming up with quite an artistically inspired view of that data and then being able to fly through it. So we talked through some ideas with some of our clients and they seemed quite into it. One COO in particular was sort of very frustrated by the fact that anytime he wanted a report, he had to get his reporting team to go and write some code, and maybe a week later they come back and say, here's a list of customers who don't have up-to-date addresses, or his favourite one actually was, here's a list of customers who are making better returns by managing their own accounts than we are by managing them for them. And he was quite frustrated about that, and especially the fact that it took him several weeks to actually get the answer back from his IT department. And we discussed an idea where we could actually present him that information on screen in a particle system, so a kind of galaxy view where we'll cluster data together in groups where we'll represent problems. So if we see a cluster over here, that'll represent data that is considered non-clean, dirty data, or data where these clients are doing that much better by managing their own accounts than having our advisors managing them for them. So all around visualization, all around manipulation of large volumes of data. And we're working on a particular example for the middle of the year around collaboration. So it'll be a bit like here, except we'll have a wall full of projectors and we'll have multiple cameras. And for those very, very dull meetings where hundreds of people come in and all want to drastically get their ideas out on the table and discuss them, instead of post-it notes and flip charts and etc., we'll all manipulate the model, and we'll do this. We'll walk up to it, we'll draw on it, we'll draw pictures, we'll make links, and we'll try and bring our ideas to life. It's proof of concept, but we're going to put that out in July and see how it goes, really, try it with a few clients. And just a couple of things, if you haven't already seen them in the news, gesture's definitely going mainstream. Samsung have announced a TV that you can gesticulate at in a fairly simple way to flip through channels and do this kind of thing, but that was shown at CES. Intel's got gesture recognition in their Ultrabook reference design, and there's various others coming. Lots of cameras coming out. The possibilities of what you can do with cameras vary quite a lot depending on the type of camera. Kinect is quite cheap and quite basic. It's based on an idea called structured light, where you fire a light pattern out and then actually try and recognize the pattern that comes back. There's a different type called a time-of-flight camera that actually sends out a light beam and measures the speed of light as it comes back to you. And they both do the same thing in the end. They construct an image of what they see in 3 dimensions. But the cost can vary quite a bit, as you can see. 100 quid at the bottom end, several thousand at the top. But they're all going to get cheaper. And I think where it really gets quite interesting as well with some of these cameras, if you think about the fact that they're actually seeing a 3D image, if you combine that with a 3D display, a true 3D display, you can create, for one example is using Mist, a 3D image that you can actually walk all the way around and interact with. Or you've got the more traditional 3D TV or auto-stereoscopic 3D TV, no glasses. So actually if I want to have an image in front of me that's got multiple layers of data that I want to manipulate my way through, then perfectly possible. So very interesting possibilities if you combine some of these new technologies. And for anyone who is thinking about doing this, some words of warning. I mean, my advice would be if you've got an idea, then definitely try it. It's quite accessible, but there are a few things that don't work quite as well as you might think or advertised. Most of the software is quite difficult to get up and working. It certainly requires a bit of persistence. None of it's well packaged. Even the commercial stuff's not very well packaged. Gesture learning, and you would think this would be in the box, but this is where it gets quite difficult. If I want to come up with a gesture that's like that, say, none of the packages will support that out of the box. Most of the ones out of the box will recognize that, possibly that, and that's about it. So you think, how do I get an application to actually learn a movement which is not particularly exact? And if you think about it, it's a lot like a handwriting recognition problem, which famously not solved particularly well by software. But what is quite good is some of the companies are coming out with AI solutions now that do actually try and solve that problem properly. So you can repeat the gesture, you can get a whole audience of people to do it, people of different sizes and shapes and heights, and the system can actually learn that gesture, because from a programming point of view, it's fairly hard. Finger tracking, I mentioned, the maths is out there. If you know what you're doing, you can do it if you've got a good enough camera. But again, some of the packages are actually providing that right now. And doing it in the web, not terribly well supported at the moment. We tried a package called Depth.js, and it's quite limited, to be honest. But it's coming, but then it's being worked on by a bunch of people in their spare time, so you can't really expect too much. The Zigfu guys in Israel seem to be coming up with something a lot more ambitious. So my point is simply there's a lot happening. There's a few challenges at the moment, but actually I'm sure they're all going to get solved quite readily. So as I said, this was just what's happening out there at the moment, give people some ideas of what is possible. It isn't just for games. There are a lot of serious applications, maybe some in financial services. There's a lot of tech out there. There's a lot of software to support you. There's a lot of hardware to support you. And I think a growing band of experts. There's a few books now, not many, but the fact that you see one or two publications gives you an idea of this stuff is starting to mature a little bit. But it is still growing very, very quickly. And I think simply we're going to see a lot of interesting stuff.
I don't mean to be negative, but outside of gaming, isn't this just a gimmick?
I think time will tell. This is part of why I'm interested in actually trying this. I've found in collaborative environments, which is where we're going to start, where you're trying to help people get their ideas formulated and expressed, sometimes a different way of interacting with the medium can actually just help people think a little bit more fluidly. I mean, we'll see. I think there are some applications where you've got big data that's very complicated, especially multi-dimensional data, and it's maybe not for everyone, but where you want to manipulate that and actually analyze it, then this ability to gesture the computer actually opens up new dimensions. And that's why I think you've got to take a prototyping approach. I can't say for absolute certain, but my feeling is that's the way it's going to go.
If you want to speak to a company that creates 3D data, there's a startup called Real Status. They help they help companies manage their IT in a 3D environment. It just makes it easier for them to see what's going on. The CTO's name is Stace Hipperson. Might be an interesting contact for you.
Thanks. I mean, there's a similar one. A friend of mine was a CIO in a big oil company, and they had a similar application where they had 3D models of their network throughout the world, which was phenomenally complicated, as you can imagine. And they built rooms like this, but screens all the way around, like a planetarium-style projection. And actually trying to manipulate your way through that with a mouse and keyboard is probably quite difficult. So, yeah, I mean, you definitely get those examples of sort of big multi-dimension data.
I actually think it's quite amazing what will be possible with this, and especially combined with other senses like voice and sound.
Yeah.
A polysensorial environment for manipulating data and computers and the real world is going to be huge, and this is one component which will go along with voice recognition and that kind of thing.
I think polysense is exactly right, because one of the other things that's coming with these cameras is facial recognition. Well, I mean, it's there, but when they can process quick enough, they can read the emotions on your face to a certain extent. If you're frowning or smiling, or there are certain macro structures that they'll be able to read. If you think about the fact if you can get neural sensing helmets that'll actually be able to read basic, well, they're there now and you can buy them, can read basic thoughts from your mind, again, targeted at games, but there are all these other dimensions that can be combined to make a very, very rich interactive experience.
Yeah, I agree. In fact, the statement that a computer originator said there'll be only 6 mainframes in the world. Who said that? I don't know, but I kind of feel the potential for this is amazing.
Yeah, that's certainly my feeling, and that's why we're putting some time into it. Yeah. Thanks.